What is going on, ladies and gentlemen? In this video I'm going to be going over pointers in Golang. So let's get started. Alright, so I kind of already have a little setup on how I want to show what a pointer is in Go, or pretty much in any language. I feel like if you understand this, you can probably understand how to do it in C++ or any other language that use pointers. If you came from C++, then this should be relatively simple. But if you haven't used pointers before, I'm setting it up in a way that can be relatively easy to digest. So let's get started. So first, what is a pointer? All right. So a pointer just holds the memory location of a value, right? So in the beginning, of the tutorial series for Go, and I talked about variables. I like to represent variables as a box that holds data, right? This box is stored somewhere in memory, right? So what a pointer does is that it just gets that location of where the box is. It gets the location on where it's being stored, right? Not the actual value, but the memory location of where the value is being stored. How that is being done, we can see right here. We have a var right here that's called p. I like to shorten it, but it's short for pointer, but it's just p. And to specify that it is going to hold the memory location, all I did was put an asterisk in front of the type. So this can be anything, right? This can be, so all the types that we learned, it can be floats, 32, 64, it can be a string, but it's just saying that we're getting a memory location of a value that is of type string or of type int or whatever we choose. But in this case, it's going to be an int, right? And initially, if we just created a variable of a type pointer that has a that has no values being stored in it, right? Let me just comment this out, save it. If I run this, and let me bring this up, and I run it, by default, right, it's going to be nil because there's nothing there. There's no memory location. There's no value in it. So by default, this is not going to have anything being stored in this pointer variable, right? Okay. So now let's actually create an item. Let's create a box with data in it, right? So I want to create another variable, right? I'm gonna call it num, and just to make sure that it's using the proper type, I am just gonna make this a var, and I'm gonna make this an int, just so that we're following, right? Because I did state above that this pointer is going to be a pointer of a memory location of type int. So I'm going to create a variable called num. It's going to store this integer value called 55. And now let's point this memory location of this box called num so that this pointer knows the memory location of this 55. Not the 55 itself, but the memory location. So to do that, now I'm going to demonstrate a new thing called the, or this is an ampersand, but it's called the address of operator, right? So what this is doing is you put this ampersand, because this is what the symbol is called. It's called an ampersand. You put the ampersand in front of the variable that you're trying to retrieve, like the memory location. And what it does is it gets this variable and retrieves the memory location of the variable, right? So before, if we just printed out num, it would just print out 55. But now that since we put the ampersand operator in front of this variable, it is going to turn this value into a memory location, right? So it's probably not, you're probably like, what is this guy talking about? All right, let's print it out and see what is happening. All right, so let me clear this out, and I want to see both of them on its own line. So let's print it out, and boom. Initially, right, this pointer was nil. There's nothing being stored in this pointer variable. But then we had a new variable that we created called num, which is a type integer, and we stored that 55 inside of it, and then we made p equal to the address of this box that is storing the value of 55. But because we're using this ampersand in front of the variable, we're saying we don't want the value, but we want the address or the memory location of this box, right? So the pointer, and I should say the pointer address or memory location, I'm going to say the memory location of p is, and right, you'll see right here, what is this, right? This hex value is just displaying where it's being stored in memory, right? It's 0x, and then it's showing the memory location of the variable, right? It's usually what we're expecting, right? We're expecting num to just show 55, right? But in this case, like I said, this ampersand in front of the variable turns this value into the memory location instead of the actual value. Now, there's this last piece, right? And you know, it's commented out right now, but it is called dereferencing, right? So to dereference a value means that if we were to put an asterisk in front of this pointer variable, it's going to, instead of retrieving the or instead of printing out the memory location like we expect above here, it's going to dereference it, and now it's going to print out the actual value of whatever is at that memory location, right? So you remember what I was saying, that how we store variables is like, you know, me putting it in a box and putting it somewhere in the garage, right? And then me pointing to it is getting the memory location of a value, right? But now if I dereference something, instead of pointing to where that box is in the garage, I am now opening the box and seeing what's inside of it. I know where it is in memory, but now I want to dereference it. I want to open the box and see what's inside. That's how I like to think of it. So it's just, instead of just getting the memory location, instead of pointing to the memory location of the box, I want to dereference it. I want to open up the box and see what's inside. I want to see the value inside of that box, right? So in this case, I have P, and it is now, before it was storing the, you know, box location, or this variable called num location, and I know originally num was equal to 55. So now that I know the location of number, right, or this num variable, I want to dereference it now. So I have to put an asterisk back in front of this pointer, right, this P, and now I'm dereferencing it, and now I can see what's inside, right? So let me clear this out. Go run. So the initial value is nil. The memory location of P is, you know, this hex, and now I am dereferencing it, so the value that is being printed out is 55, right? It's not going to print out the memory location anymore. We dereference it, and now we're going to open up the box and see what's inside, and we see that at that memory location the value inside was 55. So cool. This can be pretty powerful, and I hope that was a, you know, clear understanding, that helped clear up any misunderstanding of, you know, pointers for you. I would play around with, you know, just the, you know, basic implementations of this, like play around with the ampersand, play around with, you know, creating a pointer variable, printing out the memory locations of different things, assigning it, you know, different variables, and then dereferencing it, seeing if you can, you know, get what you expect. What makes this so powerful, or what makes pointers so powerful, is another aspect of it, is that since now that this P variable has the memory location of you know, this number, right, of this num variable, what happens if we change something within you know, P, since it's now pointing to this num variable, right? Because the memory location is where it's being stored. So what if we change something at that memory location, right? We don't necessarily have to use this num variable anymore, right? Because what makes variables so useful is that it's storing it, you know, a value at a memory location. But since now two variables both have you know, a reference to the memory location, and now we don't necessarily need num. We can also use P to change a value at a specific memory location, because they both have it, right? If I change num to 46, I can do that. It's nothing stopping me from doing that. But now I can also change you know, num from P, because, you know, P also has a you know, reference to where num is being stored. So let's try that. All right, cool. So now what I'm doing is I'm dereferencing it, and I'm making it equal to 65. So what do I expect to see when I dereference it and print it out here? And let me actually print out num as well, right, just to show what exactly is going on. All right, so let's clear this out and let's run it. Boom, right? So isn't this crazy? So before we're still printing out the memory location, right? We know that we're holding the memory location of num from above here. But initially we changed the num to equal 46, right? So why do we see 265s now? We see 265s because of the fact that since P is storing the memory location of num, when we dereference P and we make it equal to a value, it is now changing the value in the location, in the memory location of num, right? Because we're referencing num because P is storing the memory location of 65. So now, since they're both pointing to the same memory location, any changes that we make from P, num will also see as well. So they're both pointing to the same memory location, so they both will print out the same value. So that's powerful. That's also powerful, right? So if we ever need another reference, or if we need to point to a value using a memory location, it is now possible, right? So don't feel like you're restricted to just using ints and floats and stuff. We can also use pointers with structs. So let's do that. So let me just create a quick struct, and I'm just gonna call this person, just like we did in the previous tutorials when I was going over structs. And we're gonna make this a type person, and we're gonna open this up. We're gonna make a name, make it a string. This is gonna be really basic, so I'm just gonna create one attribute. This person is gonna have a name, and then let's assign it to a variable. All right, so we're gonna call this person, and we're gonna make it equal to, and I use person with an M instead of an N, and let's change that. And then I'm gonna make that equal to a person with a name of another reoccurring character, Bobby. All right, cool. So now we have a person variable with a type struct of person and the name Bobby. But now we can also create, and I'm gonna make this a variable called point, and I'm gonna set that equal to the ampersand, right? So the ampersand of person. So we already went over this. What this does is it gets the memory location of person, right? It gets the memory location of where this struct is being held. And we can print that out just to prove it. And then we do point. And let me just comment most of this stuff out. Clear. And then run it. And we shall see, boom, it is showing the ampersand Bobby, right? So to actually see the pointer value of a pointer in struct for structs, we'll use print formats, and we'll say the memory location of P, and we'll just put a format for this P, and or for person, and then we're going to pass in point, because point is holding the address of person. And then we're going to do go run, and then boom. Actually, I forgot to put the /n. I always do. And just run it again. Boom. So now we see the memory location of the struct. And if we dereference it, which we can do, let me just do that on the next line. And actually, I'm just going to use a println for this one. And then I am just going to dereference it. Remember, use the asterisk in front of it and point. And then we can just clear that out. Go run. And then boom, we see Bobby inside as expected. It's just getting the value that we expect to see, because it's pointing to the same location that person's being held, and this person is holding the value of Bobby. But now it's retrieving it because we have the memory location being stored in point. So if we dereference it at that memory location, like I said, the garage example, we go into garage, we're pointing to the box of where we're storing it. Another person points to it, right? And now to actually see what's inside, we dereference it. We open up the box to get the data. If we want to change it, all we got to do is open it up, put the new value in, close it up, and it's still going to be pointing to the same memory location. All right. So hope that helps visualize it for you. I think that helped me a lot. But if it didn't, you can leave a question in the comments, and then I'll try my best to answer and provide some other examples or some documentation that may help. Now, we don't necessarily need, say for instance, we want to change something within the struct, right? We don't necessarily need to like dereference it like we did above here. Like remember we dereferenced it, set it to 65. Golang is smart enough to know that, okay, this point is holding a struct. So if we want to, grab name, right, we can do that. Or if we want to, just do point dot name, and that person changed his name to Geo, right? And right, we're still gonna dereference it here, but we don't have to dereference it to change the value inside of the struct. Golang is smart enough to see, okay, this is a struct, this person's trying to dereference it to change the value inside of the struct. We'll let him do that, right? So let's clear this out just so I can prove it. Boom, you see that it is not Bobby anymore, it's Geo, because Golang is smart enough to interpret that, okay, this person's trying to change a value within the struct that it's holding, and we're gonna let them do that. We're gonna dereference it ourselves and actually change the value. So if you're messing around with structs and pointers, you can just think about that. Golang handles all of that hard work for you, so you don't have to worry about that. Just point to whatever you want to change within the struct, and then if you want to print it out, dereference it, and do that. But yeah, that is pointers in Golang. If you have any questions, leave it in the comment section, and I'll do my best to answer them. And I am going to mess around more with pointers in the next video when we go over functions. But this, I believe, is a good introduction to pointers. But like I said, if you have any questions, just let me know. And if you enjoyed it, leave a like and subscribe, because there is more coming.